Okay, so in this section, 4.1 to 4.2, what we're going to be doing is writing the equations of a linear function. So we're going to be looking at slope-intercept form and y equals mx plus b more in this section. So again, as you all should know, slope-intercept form, y equals mx plus b. If you already know what your slope is and you already know what your y-intercept is, you can just plug the information directly into the equation and you'll have your equation for your linear function. So for our first example, that's exactly what we are given. We are given our slope and we are given our y-intercept. So if we're starting with y equals mx plus b, we can directly plug in 1/4 for our slope, which is our m value. And then from there, we can directly plug in 4 for our y-intercept, which is b. And now we have our linear equation for this information here, which would be y equals 1/4 x plus 4. Now, if we are given a graph, you can either identify the slope by using your rise over your run and then identify your y-intercept by looking at the graph, or you can use slope-intercept form in a different way as well. And you can also use your slope formula to find your slope if you're not too familiar with counting your rise and counting your run. So for example, finding your slope, y2 minus y1 over x2 minus x1. Plug in your points. So I identified 4, 3 as x1 and y1, and then I identified 0, negative 3 as x2, y2. So plug in those points, and we end up with a slope of 3 over 2, which if you look at your graph from one point to the other point, you're going up 1, 2, 3 over 2. 1, 2, 3 over 2. So your slope is 3 over 2. So when you write your equation of your line, plug in the slope that you just found, and then you need to identify your y-intercept. Well, you should know your y-intercept by definition is when x is equal to 0 and when your graph crosses your y-axis. So by looking at the graph, you have your y-intercept, which is negative 3. So you're going to just plug that value in for b, and now you have your equation for that line. So when you're given all the information and when you're given the graph, it's fairly simple. What we're going to look at now is if you're given a little less information. So at this point, we're given our slope and we're given a point. So we have no idea what the y-intercept is by just looking at the information given. But we know we are writing the equation of a line. So slope is 2. We can plug in our slope value for m. So we're going to plug in 2 for m. Then from there, we need to figure out what b is. We need to figure out what our y-intercept is. That's where that other point is going to be helpful. So that other point is going to be x and y. So when you have a coordinate pair, x comma y, so we're going to plug 3 in for x, 4 in for y, and that way the only variable left to solve for is b, which is our y-intercept. So solve for b, multiply 2 times 3, get 6, subtract 6 from both sides, and you end up with b equaling negative 2. So your y-intercept is negative 2, and your slope is positive 2. So now you have all the information necessary to write the equation of your line. So y equals mx plus b, plug in 2 for m, plug in negative 2 for b, and there's your equation, y equals negative 2x minus 2. So now at this point, I would like you to pause the video and try this example on your own, just like what I did in the last one. So again, pause the video, try this example, and then in class we'll go over it. But moving on to our additional example, now I only give you 2 points, so you have no idea what the slope is. But luckily, we know how to find the slope. So we know how to find the slope by using our slope formula, y2 minus y1 over x2 minus x1. So from there, take your points and plug them in. So I labeled negative 3, 5 as x1 and y1, and 0, negative 1 as x2 and y2. So take those points, plug them in, and find your slope. And for this problem, our slope ends up being negative 2. So now when we go back to y equals mx plus b, we can plug in negative 2 for m. Now we need to find that b value. So what we're going to do is exactly what we did in the last example. We need to pick one of those points and plug it in for x and y so we can solve for b. Now, it does not matter what point you pick to plug in. I picked negative 3, 5, but if you wanted to, you could have plugged in 0, negative 1 as well. So from there, you end up getting 5 equals negative 2 times negative 3 plus b, so we can solve for b. Multiply, subtract, you end up with b equaling negative 1. Now you should also have recognized from this point here that our y-intercept is negative 1, because the definition of our y-intercept is when x is 0. So you actually could have figured out your y-intercept without having to do any of this work at all, because you remember the definition of what your y-intercept is. But if you forget the definition, just keep in mind you can always plug the point in and solve for b. So now that we have our slope and our y-intercept, we can write our equation in slope-intercept form. So y equals negative 2x minus 1. So with this problem as well, I'm going to ask you to try it on your own. So I'm going to ask you to pause the video and try this problem going through all the steps that I just did in the very last example. And then in class, we'll go over this one as well. So pause the video, try it out, and then we'll go over it again. Okay, another example. This is actually the same type of problem we just did. It may look differently, but is the exact same problem. So when you have f of 0 equaling 10, that's just telling you you have the point 0, 10, where 0 is your input and 10 is your output. So 0, 10, x, y. Then you have the point 6, 34. Your input is x and your output is y. So now you have 2 points. It's the exact same problem as we did before, where in order to write the equation of our line in slope-intercept form, we need to first find our slope. So I'm labeling my first point 0, 10 as x1, y1, and my second point 6, 34 as x2, y2. So plug them into our slope formula, and we end up with a slope of 4. So now when you go to slope-intercept form, which is y equals mx plus b, you know what your slope is, you know that it's 4, and you can plug that in, and now the only variable left to solve for would be b. So now I took the point 0, 10 and plugged it in for x and y. You could take the point 6 and 34 and also plug it in for x and y. It doesn't matter which point you plug in, you should get the same b value no matter what. And we actually get b is equal to 10. Now, hint, hint, b should equal 10 because by definition of our y-intercept, it's when x is equal to 0. So from just looking at the point here, we should have known that our b value, our y-intercept, is 10. Either way, we have our equation y equals 4x plus 10, where your slope is 4 and your y-intercept is 10. Okay, so I'm going to ask you again to pause the video here and try this example. So again, this example is just like the one we just did. So pause the video here, try this example, and we'll go over it in class next time. Okay, now this is another form that you could also use, but it's not necessary because if you're familiar with and you're comfortable with slope-intercept form, this form is not necessary, but I just wanted to highlight it and just kind of go over it just to show you that there is an option. So if you do go online and you see something else, this is what it is. So y minus y1 equals m times x minus x1. Either way, if you simplify and solve, you'll end up with the same equation if you just use slope-intercept form. So you only need to know slope-intercept form for this section. This is just an additional one that I just wanted to go over with you. Okay, so now let's look at just an application problem. So with this problem, what we want to do is, given the situation, to rent a van, a moving company charges $30 plus 50 cents per mile. Write an equation that represents the cost as a function of the number of miles. Identify the slope and the y-intercept and describe their meanings. So we have, still using slope-intercept form, which is y equals mx plus b, and we want to identify our slope. So remember, your slope is your average rate of change. So your price is changing 50 cents for every mile. So that word per is a helpful hint of identifying your slope. So every time you're talking about your slope and you see that word per, that most likely will be your average rate of change. Because how much is the total changing? Well, it's changing 50 cents per mile. So that's how much it's changing. So our slope is 50 cents. Now we need our y-intercept, which is $30. So that's your initial cost. So without even moving the van, just renting it alone, it's going to cost you $30. So that's your initial cost. Now you have your y-intercept and you have your slope, so you have your equation for this situation. Y equals 0.5x plus 30. Now that we have our equation, we can find the cost of the van after driving 150 miles. And all you're going to do is take the 150 and plug that in for x. And from there, you can solve for y, which is going to be your total cost. So in this case, our total cost for driving 150 miles is going to be $105. So here's another example. So the last example that I would like you to pause the video and try on your own. And then we'll go over it again in class. So again, pause the video here, try this example, very similar to the last one, and we'll go over it in class when we are done.